welcome to SD-WAN training. So in this course, we will more focused on the viptela one, okay, which is so Cisco own two SD-WAN solution. Cisco itself have Meraki, and the other one is a viptela, which they acquired recently. Viptela was altogether was a separate company, and then looking on the demand of the market, understanding the challenges and all those stuff with their solution, they bought the viptela. So now viptela is being owned by Cisco. Okay, so in this session we will be more focused on the viptela uh Cisco SD-WAN solution. So moving on, what? Mhm. Please go ahead.
viptela is a company name, Surya?
Yeah. So Viptela was the separate company. Like for an example, there are a lot of companies, Cisco does acquire depending on the, their need and their, market and all those stuff. So Viptela was the totally separate company name. And further, Viptela was being, built by a small group of, people, those registered their company as an Viptela, made the entire solution. They went into the market. Cisco see that it is the best solution to acquire, so they decided to acquire that business. And the Viptela owner or the group of those people decided to sell the Viptela. So now Viptela is owned by Cisco. Okay. Any question further on that?
Nothing. Just
So what you will learn out of this course is the SD-WAN fundamentals. Okay, what SD-WAN, why do we need SD-WAN and all those stuff, and then describe how to deploy the SD-WAN. Further, you will understand the configure SD-WAN environment. What if you got the opportunity to work on the SD-WAN, how you will configure and deploy in your infrastructure, and then deploy zero touch provisioning. So zero touch provisioning is another concept of the Cisco SD-WAN. We will get in touch in detail when we will get into the course. So zero touch provisioning is mean that you don't do any physical stuff on the device. You just connect one wire, your device is provisioned. So like that. Okay, so that's what we call it, a zero touch provisioning. You don't need to take a console and put the configuration and so on. Okay. Other one is the configure SD-WAN policy. So configure SD-WAN policy is that, SD-WAN solution does itself involve the type of the policies. So how we will configure and what are the benefit of those policies, we will talk about that. Okay. And then operate SD-WAN devices and software. So you will get to know that how to check which software is running, which device model do we need, and all those stuff. And then troubleshoot SD-WAN environment. So in nutshell, you will get to know everything for Cisco SD-WAN point of view, either the policy, routing, troubleshooting, everything you will get to know. Okay. Now further move on, we have splitted this course into the two part. One, we call it a Cisco SD-WAN Viptela Basics, which is more on that, day-to-day activity stuff. And then we call it advanced, which is if you are, level 3 resource, or you are the, SME of the SD-WAN, or you are in a design and deployment, you need to be knowing the topics which we are going to cover in the advanced. So in a basic, what we are going to cover is the SD-WAN fundamentals, controllers installation. So it does have the set of the controller. We will connect you what are those controllers and what are the functionality of those controller and how do we install those. Okay. So and then VS cloud installation. So in our lab, we don't have a physical hardware. So we will be showing you the VS cloud installation. Now coming on the point of the VS cloud hardware and software, no difference from the configuration point of view. It's just the one is a physical appliance, other one is a software appliance. Okay. Other one, go ahead.
this V-Edge physical appliance available?
Sorry, come again. Physical.
V-Edge have any physical appliance?
Yeah, VH have a physical appliance.
Physical box also available.
Yeah, same like a router. So I'll connect you about that as well. Okay. And cloud means is the software appliance which you can host on the VMware or any cloud provider like a AWS, Google, or any of them. Okay. JTP, PNP, what are those JTP and PNP? We will connect you about that. And then SD-WAN introduction to the web interface. So what are the options available in the web interface and where to check what? We will connect you about that. And generate certificate. So we have a type of the certificate options. I'll connect you about that, and how to generate the certificate and where to install those certificate, because it is pure a highly secure solution. So it does involve the certificate validation. Okay. Upload the VH serial number file. So this is more on the licensing part of it, that because this solution have the multiple mode of the security. So one of them is the whitelisting based, which is a serial number and chassis number. So we have to how to download it, how to upload it, and so on. Okay. And then further we will talk about the validate and invalidate a VH router. Okay, so there are different state. We will talk about that. Software version installed on the device, status of the we want orchestrator. So this is one of the controller which does help you to provide the auto provisioning and all those stuff. And then the status of the VS router, status of the vSmart controller, vManage device template. So there are the template. We will talk about what those templates are mean and how those templates are helpful for us. Okay. And then we will talk about the SD-WAN device common templates. So how can we create the common template versus the device specific template. Okay. SD-WAN routing, connected and static, right? And BGP and OSPF. So how can you run the BGP OSPF on the SD-WAN? Okay. VRRP configuration, DHCP server interface information, AAA, how to configure AAA and all that stuff. Okay. SD-WAN upgrade, how can you upgrade all your controller or the VS devices? That's what we will talk about. So this is what we talk about the basic, right? So what we will cover in the SD-WAN basic, right? So all this is your day-to-day operational job, right? So you need to have the basic understanding that, what the solution is, why do we need that solution, what are the type of the devices, how to do the basic routing stuff, templates, and all those stuff, right? Now, in advance, what we will talk about the policy overview. So there are, like I said, the multiple type of the policies we do have, and it is the one of the a complex stuff which you have to carefully design and write the policies. Second, we will talk about the how you can configure the BGP and OSPF, but will you be able to control the routing, that okay, I want to prefer this route over the other route, right? So that's what we will talk about. And then we will talk about SD-WAN dual transport. Okay, so what does it mean by the dual transport? If you have more than one WAN, how do you connect the WAN, more than one WAN on a site? Okay, so for an example, if you have two MPLS, how we will connect those MPLS and what are the best practices to do it. Okay. There is something, a new thing which you may never heard about it, a T-lock extension. So T-lock extension is a more on the transport location extension, and how does it work, and what are the benefits of it. We will connect about that. Other one is the SD-WAN topology. How can you write the policy to define the topology, and what type of the topologies you can write it. So what is the benefit of the writing different type of the topology? I'll connect you about that. Okay. Next we have SD-WAN ECL, firewall, traffic engineering, and all. So this is more on that, how you can do more advanced level setting into your SD-WAN, that okay, I want to prefer one WAN for this path, other WAN for the other path, and so on. So okay. Next stuff, which is another intelligent feature of the SD-WAN, is the application aware routing, which is more on understanding your application, understanding the type of the media, and then best media should be used for that application. Okay, quality of service, VPN segmentation, you know, net. So all this stuff will be covered into the advanced, which is, if you are the, senior resource in your team, how you can do these stuff and how you can understand if someone has already done, how can you read out and can understand that, okay, what is the mean of this line, what is the mean of, this application aware routing or this, policies to uh, where it is actually being used, right? If you will not be able to know that which routing or which configuration is affecting your policy, I mean your traffic, you wouldn't be able to even troubleshoot better, right? So that's the reason we combined all of them separately. Now basic is just for L1 or L2 task which you are in your organization, so you can do better job on that. Okay, and then multi-tenant side, which is more than having more than one customer on the site, same site or same device. So that's it. Any questions so far on the course containment? What we will be covering? Anything so far?
All right, it's okay. You can go ahead.
Yeah. All right, let's move on. So
One thing, Sujit, like, is it required any automation skill or programming skill?
it is not mandatory. It is the if you want to take the SD-WAN at another advanced level. Okay, so another advanced level means that, so for an example, your Nexus 9K or your, SDN or any other device does provide you two type of the functionality, right? One is that you can do the CLI command on it. Other is that if you want to be an automation engineer, you can run the API, you can use the API, you can run the sort of the automation to take it to the further advanced level. I mean, like if you are enabling OSPF by the CLI versus you are doing by the automation, at the end of the day, you are enabling OSPF. Automation is helping you to do the major rollout or to, use the set of the tools instead of, so in this one, it is not mandatory at all. It would be at the another advanced level. That's what I would say. Okay. So let's move on. Why now for SD-WAN? Why do we need it? What is the use of the SD-WAN actually, came into the picture, that why do we need SD-WAN, right? So to connect with you, what exactly is happening and what was happening with the WAN. So the traditional wide area function was the connect user. Let me take this. Connect user at a branch or campus to the application hosted on the server in the data center. Typically, dedicated MPLS circuit were used to help the ensure security, reliable connectivity. This doesn't work in the cloud-centric world. So what does it mean by that? How do we design your traditional network? We have a MPLS provider. We have a data center. All the applications are hosted into the data center, and we send your traffic from our local site to that central data center. True, right? So that's where the MPLS is providing us the secure and reliable connectivity, because MPLS is charging us more, so it is a more secure and more reliable, right? Now the problem here is that we are no more going we are no more working in the methodology what we were doing previously in the WAN point of view. So businesses are shifting towards to the cloud, right? So towards to the cloud, what cloud is the software as a service or infrastructure as a service? I hope you understand what is the mean of the software as a service or infrastructure as a service. Please let me know. I can clarify that if you need.
No, this is the first time I'm hearing this one.
So software as
I
a service. Okay. So let's say
okay, go ahead.
software. Go ahead. Sorry. Go ahead.
Yeah, you can continue.
Okay. So software as a service means that you are taking a service and you are paying for the service. You are not asking them to provide you their infrastructure to use as in the application. So for an example, if I'll give you the example, Concur is the one of the HR solution application which you use to provide the to host the HR solution and all those stuff. So what they are doing is that they are providing you the services and you use those services, right? Same like if you are the one of the organization, maybe in a finance or any other stuff, you have a lot of services which you took from the different service provider. They are hosting into their cloud, and you use basically to access the application. For you, application availability is the criteria. For you, it doesn't matter that what data center they are using and how they are. One second. How they are making the application available, right? So for you, the important part is the application availability. So that's where you are saying that software as a service. You bought the service. I mean, you bought the software, and you say that I need a service who is managing infrastructure, how you are managing the redundancy, how you are doing whatever. I don't care. For me, the service should be available. That's where what we call it as software as a service. Other terminology is the in advance is we call it a infrastructure as a service. Now you say you go back to the AWS and you say, hey, I want to use your infrastructure to build my network or BPC or applications in your data centers. That's where you got infrastructure as a service. You are paying for an infrastructure, not for application. Application is your own. You go, you launch the instance, you host your application there, and you use it, right? And you pay for the infrastructure. You don't pay for a service, right? And of course, infrastructure as a service become costly because you are using dedicated infrastructure for them or partial infrastructure from them, right? So what is the mean of that? The footprint of the organizations are increasing widely. They are using one more than one cloud provider. They are using different type of the application, different type of the services to reduce their load from the data center to the from their own data center to the cloud provider data center, right? IT is realizing that the user application experience is poor. So how it become a poor now? Think of that. Okay. So what you had previously is that you have everything in your cloud, in your data center, a central point, and you route all your traffic towards to the data center over the MPLS link. Your I mean, your link stability is better, everything is good. But now, since you are going to use the multiple cloud provider, what is going to be happen that you take all the traffic to your cloud provider, I mean, to your central data center, and from that central data center to the AWS or Azure or the I mean, or the Google, right? Or any other cloud service provider like Oracle and others, right? So what is happening? First thing is that the experience of the end user is becoming a worst because of the traffic is taking a way long path to reach to that, and the reliability of those links, you know, sacrifice, right? And then further on that, since you are involving a multiple cloud provider in your data center, connecting to your data center, the complexity is being increased, right? So that's where that because the WAN designed for the different era are now ready for unpredicted explosion of the WAN traffic that cloud adoption brings. Because since you are, going on the cloud, your traffic is increasing, your end user machines or devices are increasing. The traffic cause management complexity, application performance, unpredictable, and data vulnerability. Because if you go with the open internet, you have a lot of risk, right? So further opening the enterprise to the internet and the cloud expose major threat compliance issues. It is extremely challenged to protect the critical asset of the enterprise when the application are accessed by diverse workforce, including employees, partners, contractors, vendors, guests, enabling broadband on the WAN, making the security requirement more acute, creating a challenge for the IT in the balancing user experience, security, and complexity. So just think of that previously you have a, let's say previously you have a one data center which is fully managed by you. You send every data to that, and you have the MPLS and secure. Now let's say if you are taking a AWS, you are taking a Google, you are taking a Microsoft, you are taking you know uh, maybe Oracle or any third service provider. As number of the cloud provider you are engaging or you are shifting towards is becoming a challenge from the complexity and connectivity point of view. Now, other part of that, just just think of 5 years back, how many end users does have more than one device in office? Maybe 40%, right? Today, world is every individual does have more than two devices. Maybe one is having a mobile device, other one having the office laptop, third they have maybe some Docker machine. I mean, and then the type of the involvement has been increased: partners, contractor, vendor, guest, lot of, right? So, and then the other challenge was coming, that you need to give to the flexibility to your employees as well, right? So you are shifting towards to the cloud, and you are trying to, since the cloud is open on the internet, you have to protect yourself to, even you are sending a traffic on the internet, you have to protect yourself, right? So that's where the Cisco SD-WAN, I mean, that's where the SD-WAN is coming. That's where we need a SD-WAN right now. So we need a something which can provide us the security, which can help us to, avoid sending a traffic to the central point, so that if I want to talk to the Google, I can directly talk to the Google. If I want to talk to the AWS, I can directly talk to the AWS, right? So let me draw something for you to give you more better understanding. Okay. So let's say this is your DC. You have cloud, which is MPLS cloud. Okay. You have MPLS connectivity coming here. You have one remote site here. And other remote site here. Now, what is happening if you want to previously, what was happening if you want to access the resource, your data center, you took the resource and you come back, right? Similarly, if this side want to talk to this one, pull the resources, come back and done, right? So your traffic is limited to the MPLS. Now, today, you are expanding your footprint to, from reducing the load from data center to the cloud. So let's say here is the AWS. And here you have, let's see, GCP or Google Cloud, or maybe third you have, you know, other software as a service provider, whatever it is. So what is going to be happen? Your traffic is from here to here is going to the AWS, returning back, or if this is trying to access to the GCP, it is going to the GCP and returning back, or so on. So Now what is happening? Let's think of you are right now having a small setup, but what if you have more than 1,000 sites, right? And you have maybe a regional or central data center. What is going to be happen? Your traffic is going to the your MPLS data center, and then all the traffic is taking the a longer path. Now what if I do have a something which can let me talk to directly to this? What if I have anything which can directly talk to this? So treat Google provider or the any of the cloud provider as one of my site. That's where I can gain the benefit, right? But I cannot compromise the security, right? So to protect the security and all those stuff, the Cisco SD-WAN type of the solutions are coming, which are going to help you to protect your traffic and to better connect to the cloud provider. What you are doing is that first thing is that you are increasing the response for your remote site, as well as you are reducing the load of the MPLS on this location, right? Because at the end of the day, all the traffic is going towards to the head end.
Can I
Any
ask
question?
you?
Yep.
Yeah. Same thing we can achieve with the VPN, right?
Yeah, but what if you do start doing the VPN for different locations, different? So let's think of, you have 1,000 site. What is going to be happen is that you are having a 3 cloud provider, okay? GCP, AWS, or maybe a Microsoft or any other, right? What is going to be happen is that how many tunnel? 1,000 site are going to have the 3 tunnel for all 3 locations, and then how many tunnels you have to maintain. Just think of about it, right? So your overhead is going to be increased. Second thing is that VPN is not going to provide you the dynamic failover, right? What if that link fail, or what if that link is performing badly, right? So that's what I'm saying. The organizations are increasingly going on the cloud, a type of the service they are using. We need a different thing which can a software defined type of the WAN, where you can do this everything from the software and can dynamically let it operate, right? Clear?
Clear, but see, if I'm placing an SD-WAN,
Mm-hmm.
how I will get a redundancy and other things?
Okay,
Anyway, I have
so
the same internet connection, right? One internet connection only, right?
it's up to you. You can have more than one internet connection. It's up to you how many and of course internet is cheaper than the MPLS, right? So you can buy more than one internet. You can put more than one device at the site, right?
This cloud, when I'm taking a cloud services, for example, infrastructure as a service, if I'm taking a cloud services,
Mm-hmm.
then I need to place one SD-WAN component in
Right,
cloud also.
right, true.
Okay.
So you will.
Then I want to enable any VPN. If I have a multiple internet connection, automatically redundancy,
So
everything will happen, right?
what it is going to do is over that internet, it is going to form the dynamic IPsec tunnel. So instead of the manual tunneling, it is going to form the dynamic IPsec tunneling. On top of that dynamic IPsec tunneling, it is going to run the routing protocol, which is going to help you to shift the traffic over the one device to the other device, or one link to the other link.
That means I can go through the right directly. I can branch can reach to
Cloud provider.
for a cloud provider, or
Yeah.
I can go through the data center, right?
Yeah, data center should be a least prepared path, because you have to
But there is
reduce the load on the data center.
a redundancy, right?
Yeah, you can even cap it for a redundancy depending on the design you have altogether.
This cloud when we are taking cloud services, we don't want to worry about the multiple internet connection, right? Cloud will be providing one internet only, right?
Yeah,
Is
cloud
there
would be, no, cloud would be provided over the internet, But what if you have only one internet and your that internet went down on your side? So of course we agree that the cloud side there would not be any outage from the internet point of view, because they have built that level of redundancy.
That
What
we
if you
don't
have
worry.
hmm,
That we don't worry about the cloud internet, right?
right, you have to make sure that your type side of the internet should be always available.
Clear, clear.
Clear? Okay.
Got it.
Okay. So what is the Cisco SD-WAN? Now we will little bit, now we will more focus. So far we understand why do we need SD-WAN, because of the way drastically the changes, organizations are adopting the changes towards to the cloud. Software as a service or infrastructure as a service become a more complex to manage the infrastructure. So we need something which can help us to quickly deploy the site, quickly connect to the different cloud provider, and something which can be a better secure solution over the internet, right? Now what Cisco SD-WAN is doing for you? So Cisco SD-WAN is about ensuring that business application levels the optimal transport. For an example, it does do the intent based SD-WAN. So what does it mean by the intent-based SD-WAN? Is about leveraging the business use cases and business outcome as a basis for the WAN design, rather than building a WAN based on the transport and then deciding how the traffic engineer should meet the business requirement. So just think of for a moment. So how do we design the site? Is that we design the solution first, and then whatever the transport is available on the site to accommodate the design is, the design is accommodating whatever the type of the transport we have is good, or we see the type of the transport and then design the solution. What is the best? So there are two options. One is that I say, okay, Vishnu, I have a design which can take any type of the transport you have on the site, you can run this solution. Okay. Other one, I say that, okay, Vishnu, I don't have any solution. Based on your transport, I will design the solution. Which one is good?
Sorry, Rohit, can you repeat one more time?
Okay. So let's think of, okay, I am the solution owner. Okay. And you are my customer. Now I see, Vishnu, I have a two option. One is that I have something which I have designed, and no matter which type of the transport you have, when I say the transport is which type of the provider you have, like internet, Vodafone, MPLS, LT, is good, versus that you tell me that what transport you have and then I will design. Which one is good? So to connect you back, what SD-WAN is just providing you, they are saying that we are building a solution. No matter what type of the transport do you have, you don't need to do the re-engineering all the time. Being a designer or being a solution owner, you have done the once the engineering. The only is that whatever the transport will be connected, the engineering will follow that rule. So that's what it is saying, that intent-based SD-WAN is about leveraging a business use case and business outcome as a basis for the WAN design, rather than building a WAN based on the transport and then deciding how the traffic engineer to meet the business requirement. So I am saying that I have globally designed the solution. The solution will work, beat any type of the site you have. It will work. Any type of the link you have, it will work, right? So the Cisco SD-WAN solution is agnostic with the regards of the transport network. So it can be any kind of the kind of the transport, including internet, MPLS, L2E, layer 2 switching, layer 3 routing, LTE, or any mixer of the transport. So I am saying that the SD-WAN solution is doesn't matter that what transport you have underlay. Internet, MPLS, Vodafone, Tata, what type of the link you have doesn't matter for us. It says that the solution is being built once, the policy has been written once, whatever the transport you will have, it will follow that. So that's the beauty of that. You don't need to redesign the solution for each site. That mean to say you are decreasing the workload of your design team. You are decreasing the workload what your team has to do every time. Clear?
Clear.
Yeah. What challenges does SD-WAN solve? Consider the traditional WAN design. I'm connecting you back to the one which we were talking, before one slide back. Business makes the decision based on the cost requirement, return on the investment, and value add. Of course, none of the business will invest without looking at what the return is coming, right? So the business will invest based on the what they are getting a return out of it and what they have overall the cost of that solution, right? Now, based on these consideration, a decision is made on what WAN transport to utilize, as well as how much redundancy is required, right? That's how we do. If it is a critical site, it have a more business, it have a more money, we do the redundant side. If it is a small site, sales office and all those stuff, which is having less revenue and all those stuff, we do the design the non-redundant side, we take the internet or we take the MPLS depending on that, right? In some remote locations, the availability of the transport can be a limiting factor. Before any of this is done, at the end of this process, a business has the business requirement and WAN transport with the which meet them. So if I'm not sure you have seen this challenge before, there are a lot of locations where the MPLS type of the circuit is not available. Maybe where even the broadband internet is not available, right? There is a LTE or there is a 4G type of the connectivity is available. They follow that, right? So that's where SD-WAN is solving that. No matter what type of the transport you have, no matter that where you are going to build that solution, at the end of day, if the site is able to get any type of the transport, they can run the business. At this point in the traditional WAN design, network architect must begin the engineering, the routing to meet the business requirement, utilize the options available from the carrier. Let's look at few. Okay. So in the few, how, just connect you about the challenges what he had before. So MPLS layer 3 VPN. Okay. Organization shares their routes with the carrier in order to establish the reachability between the site, right? These require coordination with the carrier or to honor any QoS marking to establish the peering and allow the traffic engineering. So if you are taking the MPLS services from any of the service provider, what you have to do, you have to work with them to establish the peering. You have to work with them to allow the traffic engineering, QoS and all those stuff. You cannot do without without them. You have to follow that. So that's the one limitation of that solution, right? MPLS layer 2 VPN, also known as a VPN VPLS. This simulates a layer 2 adjacent LAN. The main draw of the VPLS is allow organization to utilize IGP across the WAN, right? And the control routing without the need for the carrier interaction. From the QoS perspective, marking still has to be on coordinated and honored. So first thing is that by the layer 2 VPN, you can ignore the sharing your routing with your service provider and all those stuff. You can do the traffic engineering, but the problem is that your QoS still has to be worked with in the alignment of the service provider. IPsec doesn't provide you the dynamic routing and all those stuff. DMVPN, DMVPN over the internet, very popular in more recent cases. This solution provides a lot of advantage with the only one real disadvantage being that the transport itself is unreliable in some countries and carry a very poor SLA. So this solution DMBPN does work only on internet so far, right? Now, what does it mean by that? Because it is working only on internet is not always the reliable, right? So if any, because of the low cost, the low confidence, high bandwidth nature, internet transport DMBPN tends to be used either the backup connectivity. So it is not being considered, DMBPN never being considered as a primary connection because of the unreliability of the type of the internet, right? Type of the transport it use. Any question, Vishnu, so far on this?
This is clear.
Okay. Now, how does Cisco SD-WAN solves these challenges? So just think of that, we had plenty of challenges with one, with the other, and so on, so, right? Now, viptela established an overlay network across disparate transport in order to allow the policy to be consistently designed and applied. So first line is saying lot. Just think of viptela is establishing an overlay network across the transport, okay, in order to allow the policy to be consistently designed and applied. So what does it mean by that? If you have an internet and you have an MPLS or you have any type of the transport, it is top of that, it is building up its own virtual overlay. What does it mean by that? It's virtually forming its network on top of those transport, right? Since it is forming that virtual transport, it can design the policy, and those policies can be applied to all the devices, no matter it is connected to the MPLS or it is connected to the internet, because it have by merging up all of them on top of the one layer, it says that now all of the transport for me is the same. Okay, by creating a fabric on top of the transport, we can utilize the best transport to satisfy the business intent. So what does it mean by that? We can utilize the best transport to satisfy business intent is that based on the one thing, of course, you have the different transport and all those stuff. You build out overlay, you design the policy, everything. But what if the transport is not at all, meeting those requirements for the business? So that's where you can configure the set of the, you can monitor that underlay transport. When I say the transport is the MPLS or internet, and that can affect your traffic forwarding. So the fabric can react quickly to changing the condition to ensure the business continuity. So let's say if I have more than one transport on one side, and if one transport is not for functioning correctly, the traffic should shift back on the other transport which is performing better, right? Clear?
Yeah, clear.
Okay. Other one, what we have, the SD-WAN solution overview and component. With Cisco SD-WAN solution, it provides the separation on each level. Like, so how does it form that entire solution? Now you will connect it, what is, how it is forming the solution. So first it is saying that separation into the orchestration. So when we say the separation, what does it mean by that? Each component is separate and independent to each other. They are not dependent on any one of them. So that can function their functionality same, like let's say for an example, Windows team is independent to their own functionality, their own group. Similarly, network is independent to their own group. Application or database guy is responsible for their own thing, but doesn't dependent on any of them, right? So separation in the orchestration, separation in the management plan. Management plan is again the one which is helpful to manage the infrastructure, right? Separation in the control plane and separation in the data plane. So if you understand, the control plane is more on to how your routing should build up. Data plane is that how you forward the traffic. So each of those four plane are separate to each other, mean that the either of the plane goes down, the data traffic will remain low. So orchestration, what is the use of the orchestration plan? Orchestration layer or the plan provide automatic onboarding of the SD-WAN router in the SD-WAN enabled overlay. So orchestration means is that something onboarding automatically, orchestrate, which is more on the connecting to the automation part of it, right? So orchestration layer, what it says that any of the new device want to onboard, automatic onboard, I will provide you the automatic onboard to join the SD-WAN overlay network. So what does it mean by that? If there is an overlay is being formed, your traffic is going on, and new device want to join your SD-WAN, how he can join? First, he need to go to the orchestration plan, right? And then it will do the validation checks and all those stuff and let it on board, right? Second is the management plan. Management plan help the central configuration and monitoring of the SD-WAN component and overlay. So what it is doing is that a separate plan, which is doing primarily a central management of your WAN. So how you did in the past is that you go on each device, you make the changes, you look on your tools to see that what is happening on the device, or you go back, log in on the device, see that what is happening. Now you can do from the one place that you can configure entire WAN, right? Second thing is that you can also monitor what is happening in your WAN across the globe from that one place only. Don't you think it is a cool? Of course it is, because it is helping you to reduce the operation burden. It is helping you to go back, look on the 1,000 device that where is a problem. You can directly look on the one plan. You can, do the central configuration. Let's say if you want to modify the SNMP ACL, what you have to do is that you have to log in on each device and then do it, right? But management plan is saying that, hey, no, from the one place, you will make the changes on all those 1,000 devices in one go, right? Other part does what I have is the control plan is helpful in building and maintaining a network topology based on the control plan, taking decision, all the traffic flows. So control plan is the plan which is more on to establish your routing information and to exchange your routing or control plan information, that how your topology should look like, right? Once that control plan is being done, right, what is going to be happen is that your data plan will follow that control plan information and will forward the traffic. So data plan is responsible for forwarding a data traffic based on the decision taken from the control plan, right? So what does it mean by that? It will see the traffic from the, it will use the control plan information to forward the data traffic. Any question?
Okay, clear.
Okay, very good. So now who is sitting in which plan? Okay, so orchestration plan, there is a separate device, we call it a B bond. This guy, B bond is sitting on the orchestration. Give me 1 minute. So orchestration plan is the one which is sitting on top, right? Why it is sitting on top? Tell me, guys. I mean, what is the reason why you are seeing the orchestration on top?
He is controlling everything, right?
Orchestration is the one which is giving you the entry, which is giving you to permission to onboard. So for an example,
Onboarding means it's permission to give connecting the devices, right?
right, to join the something running. So for an example, how you you entered into your organization, or how do you get to know that, I mean, how you entered into your office is that there is a one punching machine is sitting there, right? You punch your information, it check in a backend that you are right employee or not, and then it open the door, you get into it, right? That is your first entry point. Same functionality is being taken care by the orchestration. The orchestration is sitting on the entry gate, that before you enter to my solution, before you enter to my SD-WAN protected network, you have to pass through me. And I will check certain information from you and will say that, okay, you are good to go to the next layer, which is management and control plan. And then further last is the data plan. Because when you end up into the data plan, you are ready to forward the traffic, right?
The orchestration plane actually vBond only placed in orchestration.
That's true.
Management plane means vManager, vSmart, and this tool, right?
No, management plan means we manage, control plan means we smart, and the data plan means we edge or the C edge, whatever it is you have. Okay, so four plane are split it to each other, and but I mean, it is a process is being made, but doesn't mean that if the one plan goes down, the other plan will be affected. No, the functionality of that plan will stop, rest everything will work. So for an example, let's say for a running network, what if the vBond goes down? The only new device will not be able to join the SD-WAN fabric, because that is the entry point. Because if your punching machine is misbehaving or is not working correctly, no one can new enter into it, but those who are in office can still talk, can do whatever want to do. True? Hello?
Yeah, I'm getting. I'm writing also little notes. It's
Yeah.
okay, right?
Yeah, keep taking a notes, which will help you to further connect and re-emphasize those stuff, right? Now, so what I am trying to say is that orchestration is providing you the automatic onboarding as far as you have the right information to match it. Okay. Next, what we have, the management plan. On the management plan, just give me 1 second. Huh? I think my laptop battery is down. Give me 1 minute. Okay. So what management plan is doing is that it is giving you the capability to look your entire WAN from one place. First function. What does it mean by that? You can see that what issue is happening on which of my site from here only. Okay. Second, it does provide you the uh, the central repository to do the configuration on all your devices from one place. So what does it mean by that? If you have 1,000 of devices, you can configure all of those devices from this guy only. Third thing is that, of course, the API, you can configure automation to connect the API, do the sort of the automation framework, which further can explore to post the different type of the configuration or collect the set of statistics. So it does support the API, application programmability interface, right?
Statement, Sujit.
Sorry.
Before API, your statement was what?
So what I say that uh, it does
What's
provide
the
you the central repository to do the configuration for all of your devices from one place, right? And then third is that it does provide you the capability to do the automation and API use of it. Clear?
yeah.
Next, what we have, the control plane. So the control plane is the brain of the solution, because this guy is going to take care and tell to the downstream devices, to the data plane, that this is how you should be forwarding a traffic, right? It's same like, you know, this guy is instructing that this is the information you have, to same like, you know, Google Map or any other information. It does cascade that information, and the, you know, date VH devices or the CH devices which are sitting on your remote locations should follow that path, right? Because the information is being cascaded by the control plane. So it seems like the your CEO instructed something, and then your organization does follow that, right? So control vSmart or the control plane is responsible to instruct the data plane that this is how you should forward the traffic, right? And the data plane is the one who is sitting on your remote site. So all the devices which are sitting into either in your data center or on your remote site, which are, you know, involved in the forwarding a data plane, I mean data traffic, are called a data plane. Clear? So you can have the any type of the transport, like you have internet, you have MPLS, you have 4G. Now, just to very much clear to you, this part is the central part.
Plane
So
is vSmart, right? vSmart is part of control plane, right?
vSmart is a part of control plane. Okay. So all the top layer which I put in the box is is not the one which has to be put on each location. These are the devices which has to be put into the central location. It can be on internet or in your data center, right? Both deployment are being supported. So you can connect, I mean, you can use any of the VS, MPLS or 4G to reach to these controllers. And then further you can join your SD-WAN fabric. Now you can see on this one, it says a secure control channel. On top of the MPLS or internet or 4G, it does build out its secure tunnel to exchange the information between the VEdge to all top three controller, vBond, vManage, and vSmart. So if it is sending any information from the VEdge to the vSmart over the internet, it is fully protected because it does form the already a secure tunnel. Now, if new device within this SD-WAN fabric want to come, let's say this device got the internet and want to join the SD-WAN fabric, first it will go to this guy. Second, it will go to this guy. Third, it will go to this guy. Once that is have been done, this guy can directly talk to this guy or can talk to this guy. So first step is always to go to the vBond, right? And then vManage and vSmart and so on. Clear?
Yeah.
Okay, good. Now, same thing what we were talking about, the secure virtual IP fabric of this Cisco SD-WAN secure extensible network is made up for the four fundamental component. Those component we have talked about is the vManage. The vManage is the NMS centralized network management system that let you configure and manage the entire overlay, simple and graphical dashboard. Other one is the vSmart. The vSmart controller is the centralized brain of the Cisco SD-WAN solution. Why we say it a brain? Because it does have the control plane power. So the one who have the control plane power become, of course, the brain, right? Controlling the flow of the data traffic throughout the network. The vSmart controller works with the vBond orchestrator to authenticate Cisco VS devices as they join the network and orchestrate the connectivity among the each VS servers. vBond orchestrator The B-bond orchestrator automatically orchestrate the connectivity between the VS router, vSmart. If any VS router or vSmart controller is behind the net, it is formed as in the initial net traversal. The VS router is the same which we talk about the forwarding a data traffic and all those stuff. Any questions so far on this?
Okay, almost okay, clear.
Now, how your SD-WAN topology look like? This is how your topology look like. So we have SD-WAN topology, where we have one site which is having the 2 VH, okay, and other site have the 1 VH only. However, both of the side does have the 2 internet. So internet 1, internet 2, both are internet. No difference from that. Now we have a central point somewhere on the cloud or on the internet. We have hosted the vManage, vBond, vSmart, and vSmart are in the redundant form. So just we are saying to vSmart. Okay.
Is
Now
it available cloud solution for this?
come again.
Is it available a cloud solution like a vManage, vBond, vSmart, everything?
Yeah, you can. So basically, it does provide us the 2 type of the hosting. I'll connect you about those. One is the you can host into the Cisco cloud, or you can host in your AWS. I mean, or in your data center, whatever.
Or both.
For in summary, the controller should be reachable on the internet. Okay. Now I'll just connect you about the so one internet, another internet. So internet is internet, no difference, right? Either you take it from Vodafone, or you take it from Tata, or you take it from anyone. Internet means internet. It is an open internet again. Okay, there is no protection, nothing, just the open internet. Now what we do is that since we are having a 2 internet, they provide us the capability to define, to uniquely identify a transport. Is that one transport they say as in a bridge internet, other transport they say as in a public internet. What does it mean by that? They are giving you the color name. It is nothing, it is just to uniquely identify that the which interface, which uh provider, which color the traffic is going, right? So here one both the transport are terminated on 1 VS. Here both the transports are terminated on different VS. So the simple topology depicts two public internet transport, SD-WAN controller, 2 vSmart controller, and vBond orchestrator, along with the vManage management GUI that reside on the internet, are reachable through the either of transport. So it says that the SD-WAN controller, the vSmart and vBond orchestrator, along with the vManage management GUI that reside on the internet, are reachable through the either of the transport. What does it mean by that? Both the transport can reach to these guys, right? Now at each side, we as router are used to directly connect to the available transport, right? The color is used to identify an individual WAN transport, right? So it's just the you identify the uniqueness of the transport. Rest nothing. I mean, it is, you can use any color. It doesn't mean that you should use this color or that color. You can use any color, right? So different WAN transport are assigned with a different color, such as MPLS, private one, Biz Internet, Metro Internet, LTE, etc. Topology uses the color called Biz Internet for one of the internet transport and other one for the public. So we have two transport, we have controllers. Controllers are reachable from each VH over each transport, right? And each transport we did assign the one color to uniquely identify the transport. And then further we are going to form the tunnel and all those stuff. Clear? Any question, feel free ask.
So far, good.
Okay, let's move on. Now, we were talking about, let me clear this one. So this is the internet, okay? This is the internet and this is the internet. And these guys are also hosted on the internet, right? Now think of if this guy is trying to make the exchange the information to the B-bond, or vManage is sending the configuration like we were talking about, that vManage does send the configuration to the VH devices, or it is sending other info control plane information from the vSmart to this guy over the internet. What is going to be happen? Anyone can capture the information in between, right? If it is just open information, anyone sitting on the internet can hijack that information, can capture it, right? And that's where he can get into our WAN. Clear? So what we need to do is that to protect, to protect from any of type of the attack or any type of the capture between, is that we run the form of the secure tunnel. So this device does form the secure tunnel for each of the controller, vSmart, vBond, and as number of the controller it will have, it will form those tunnels. Now that type of the secure tunnel, what we call it is DTLS tunnel, datagram transport layer security. So what DTLS is mean is that DTLS is a protocol which is the another version of the TLS. So TLS we use for HTTPS, or so TLS is came after the SSL, right? So TLS does provide us the security, and the DTLS does provide us the datagram transport layer security over the dynamic tunnel which we form, and it does do the based on the UDP discovery. Okay, so there are two type of the protocol which we can run to form the tunnel. One is the DTLS, which is based on the UDP, and TLS is based on the TCP. So what it says, the VS router form a DTLS tunnel or a TLS control connection to the vSmart controller, connect to the both of the vSmart controller over each transport. Each VS router securely connect to the VS router with the IPsec tunnel at other side. So over each transport, the BFD bidirectional forwarding detection protocol is enabled by default and will run over each of these tunnels, detecting the loss latency, jitter, and path failure. So think of, let's go back a little bit on the previous topology. So one is that VS is forming the vManage tunnel, vSmart tunnel, and vBond tunnel, right? All these tunnels are being formed over this internet. What is the type of these tunnel are? DTLS or TLS. The difference between DTLS or TLS, what is that? DTLS is a UDP based and TLS is the TCP based. That's the only difference. Okay.
That's only. Any high security something? Nothing.
Right. It does provide you the high security.
Which one? DTLS, right?
Security comes under both of them. Majorly, you will see the DTLS is run by default. We don't go with the manually changing the TLS. So, well, connecting back on this one, the so far you understand that we
Yes,
form
yes.
the secure tunnel from the VH to the controllers, to the controllers. Now, what we additionally run is that each VS will have the IPsec tunnel from one VH to the other VH. So from here, it will take another tunnel via the orange path. And you see the orange is being extended until here, right? Similarly, it will have the one tunnel over this path, which is blue here extended to this guy. And then other tunnel it will have to this guy, right? So in total, how many logical tunnel it build? This guy build 4, right? 1, 2,
Yes,
3,
for
and 4. Why it built the 4 tunnel? Can you help me to understand if you got little bit logic?
because we have a two internet connection and two VH.
Right.
Each
So each BS is getting a 2 transport, and because of each transport get the I mean each device got the 2 transport, it build a 1 tunnel for each transport for each device, right? So in total this side 4, and from here it will build 1 and 2. I mean, I'm sorry, uh 1 this, 2 this, right? Here 1 this, and 2 this, right? So that's how each VS here build the 2 tunnel, because other side it have the only one device, right? So now what is the type of these tunnel? Is the IPsec. Okay, so what type of these tunnels are? All these tunnels between the VH to the VH are IPsec tunnel. What are these? IPsec tunnel. So just think of that your data is even going over the internet, it is being protected by the IPsec layer. Clear? And IPsec is one of the most secure protocol over the internet, right? Now, in addition to IPsec, what it does is that it run the BFD session. So what it run? BFD. Same BFD which you use into the other routing protocol to quickly converse the path failure. We call it a bi-directional forwarding detection. Bi-directional forwarding detection. So what it is doing by that is that it is going to first is that it is going to see that end to end, because BFD run from the one never to the other never, right? So if any of, and it run on each tunnel. So let's say if this path fail anywhere, either on the data center side, I mean on this side or on this side, it will immediately notify that there is a path failure, and the IPsec tunnel will go down, right? So BFD is first thing is that, you know, helping you to provide the quick convergence, one thing. Second thing of the BFD we are doing is that we are recording the cap efforts, how much time it is taking from one place to the other place. That's what we call it a latency, right? So BFD is also helping me to get the latency. And then of course, if it lost the any packet between, it is being considered that how many packet loss on the BFD, right? Third thing is that in addition to IPsec, I mean BF packet loss and latency, it does also help to measure the jitter. So that's what we are saying, that IP, each VH to VS, depending on the number of the tunnel, I mean transport, it will form the IPsec tunnel, and top of that it will run the BFT. So each tunnel will run the BFT, and which is a default behavior. You don't need to configure BFT or IPsec. As soon as they see the reachability, they got authenticated, they will form the IPsec. Clear? Any question, Vishnu?
Clear.
So VH to the controller, control connection, or the type of the protocol it use is the DTLS, and the VH to VH is the IPsec tunnel with the BFT. So that's what we talk here, is the VH router securely connect to the VH router with the IPsec tunnel at other side over each transport. The bidirectional forwarding detection BFT protocol is used to enable the default and will run over each of these tunnels to detect the loss, latency, jitter, and path failure, right? So if the path failure, it will immediately trigger to the routing protocol, which is running on top of it, that you have to converse the path. Okay. And if it is the loss or latency, intent-based test routing will come into the picture to enforce the traffic on the other better path based on the SLA measurement you run on top of that. Okay. Next, what we have, the color. On the VH router, the color attribute help to identify an individual WAN transport tunnel. You cannot use the same color twice on the single VH. So first thing is that color is an attribute which we use to identify individual WAN transport. Second thing is that you cannot use the same color twice on the same VS. So the color by themselves have a significance. Now to connect back you that what does it mean by that? If let's say this guy is having a right now two transport, one this internet, right? Other one this internet. On this VS, we cannot give the same color to both the interfaces, where one is internet terminated and other internet. You cannot say biz internet, biz internet. You have to say biz internet and then another second color, whatever you can say, public internet or any other type of the color you want to do, right? And there are fixed type of the color which you can use. We have set up the list there. Okay.
Color means we are adding some tag or something to
Color
identify
is
the
means is that you are tagging something, but when you will configure, you will see by them these names, like so for an example, if you see the colors I'm sorry, colors metro ethernet, MPLS, private 1, private 2, private 3, private 4, private 5, and private 6 are considered as in a private color. So color are itself split into the two parts. One is the private, other one is the public color. So public colors are 3G, biz internet, blue, bronze, custom 1, custom 2, custom 3, default, gold, green, LTE, public internet, red, silver. So the color, sorry, go ahead.
find names or
These are
like
the names. These are the names.
it's a predefined names or we can
These
configure any name.
predefined name. Predefined name. You can select either of them, but those are predefined. It does not say that, okay, you have to always say private 1. You can say private 2 as well. But the only difference is that these are the fixed. You cannot say Vishnu. You cannot say AKA. You cannot say Ramu, whatever, right? You have to only give the color name based on this pre-selected number colors, pre-built, pre-populated, I would say, not pre-built, pre-populated. Okay. Any confusion?
Okay.
Hello.
Clear, Sujit. Let me just write it. Okay. Okay, Sujit. Done.
So next we will talk about the deployment of the controller. So I think we, okay, let me connect little bit on the deploying controller. So installation of the controller, how do we do? Is that we obtain, you can obtain the documentation software, verify the system requirement, that what is the system requirement, which you don't need to do it, you have already done. Important OVA file can be downloaded. uh, Import OVA. Okay, I'm sorry. OVA can be downloaded and can be import. Perform installation and initial configuration. What are the initial configuration? First thing is the connectivity, which is IP, gateway, and DNS. Of course, you have to give it to this. This is a basic information which you have to give it to any device when you configure to make the basic reachability of it, right? Next, what we have is that system IP. So system IP address is the unique IP address, which is a 32-bit value. Same like a router ID we have into the OSPF to start the process. Similarly, into the SD-WAN, if you want to start the SD-WAN functionality, you have to give the system IP address. Without system IP address, your tunnels will not form. So the system IP address can be any number, which should be a 32-bit. That's it. It doesn't need to be routed. It doesn't need to be do anything. It should be written in the configuration. Okay. And if you will give into the systematic way, of course you will be good. If you are not giving in the systematic way, you will be little bit in trouble if you are doing in the bigger design, right? Site ID is another important attribute which has to be carefully designed. When I say that which has to be carefully designed, is that when you are actually working on, for any of your internal customer or other enterprise, is that site ID has to be well planned, because this information will be used in a policy in a future, that what type of the control plane you want to form on that site. So let's say you want to segregate a type of the site between the region or within the region, that how you will, and you want to write, give us some one policy to be applied on the one region, other policy to be applied other region. That's where this information will be very, very useful.
You mean every office is under one site ID?
Every office will need at least one site ID. So each office will be mapped with the one site ID. Okay, so for an example, you have one site is in Delhi, would be having one site ID, other site is in Bangalore, would be having other site ID, maybe third site in, Kansas City in US will have the different site ID and so on. Now, if you want to apply, you want to say that, okay, for India or for APAC region, I want this policy, then you have to your site ID to be very much consistent. So you can, geographically plan that, okay, these are the site will have this policy, these are the site will have this policy, regional hub and all those architecture. I'll connect to you on the documentation part of it.
Sorry, multiple site I can give the same site ID? Is it possible?
Uh, you can give it, but the disadvantage of being that is that those sites will not never be able to reach on the web. What does it mean by that? When you give the same site ID, it assumes that these devices are sitting on the same location.
Or if, is it possible like a, for example, India, you have a 4 branches.
Mhm.
Okay, each branch you give a separate site ID. In case if I want to apply some policy to entire India region,
Mhm.
is it possible I can combine this 4 site ID into one site ID?
Yeah. So what you can do there, we call it a site list. So we will
Right.
call out all those 4 site ID within that site list, and then you will apply the policy. That's what I said. If you
It's
are
like
designing at a
grouping.
big scale, you have to structure your policy in very structured manner. There is very good document written by Cisco which you can refer to understand that how we should define the site ID, what are the type of the sites we can have it. So let's say for an example, you have a small office, home office type of that. So for those small office, home office, of course, you will not send a full routing information and all those stuff, right? So you can design a specific site ID for a small office, home office, and when you are applying, creating a policy, you will call out that range of the site ID into the site list, and then you will say that okay, filter this to this site, right? That's where it will be helpful to build the common, what we call it, to build the policy into the SD-WAN. Clear?
One more thing, so the
Yeah.
system IP means which we are configuring an IP, right? Normal IP process, right, or
Yeah,
something else.
it would be same. It just the it would be given same like you did in the router OSPF or in router BGP. What you do, you go inside the BGP and you say system I router ID
You're
this,
trying.
right? Router ID 1.1.1 or whatever you give it, right? Similarly here you will give system IP under the system IP address 1098.21.1. As soon as you will give it, your process will start. If you will not give it, your control connection will never come up. So these are the few important information which has to be there. Okay. Next, what we have is the organization name. Organization name should be matched to get it approved and to get it to join the overlay. So for an example, if your bond, manage, and other VSs are set up with the organization, let's say ABC, then any of the VS joining that fabric should have the same organization name. So your organization name should be a consistent across your globe, across your organization. Clear?
Every device should be under same organization name, right?
Right, true. Every device should be under the same organization name. Clear? Next, what we have is the bond and address. So bond is like, if you remember what I said, is that the bond is the entry point. So you need to know, your device should know that what is your entry point to join the SD-WAN fabric, right? So your each of your device should know your bond information. So you should give the bond address that this is the first entry point where you need to enter. Once you entered into it, then entire internal onboarding process will take care. You have to first go on that, right? To same like if you want to join any of the company, you want to get into enter into that company, you should know the address of that company to reach on the right door. Once you punch on the right door, there would be guards and everyone, doors will be further open. You will keep following the process and keep getting into it. Clear?
It will be a DNS or like a IPOB,
It
public
can
IP or
it
something.
can be both. It can be both.
It will be public IP, right?
Sorry,
It's a public IP, right?
it would be public IP address of your, or it can be a if you have made a DNS entry of public, DNS entry corresponding to your public IP address, you can do that as well, right? If you will give the name, then it will use this DNS server to resolve that name and will get the IP address and will form the tunnel, right? If it will get the IP address, then this process will be eliminated and will be directly reaching to the B1.
Like a, you mean it's a, we can do the natching and then provide an IP, or it should be directly public IP?
It can be anything, as far as it should be the publicly reachable. You can have the static one-to-one netting. Okay. You can host it in your DMZ, can do the pub one-to-one netting. Okay. NTP is not mandatory attribute. It is being used just to make sure that the clock is same, because certificate, like I mentioned, that certificate is used for making it more secure. So NTP does come into the picture to secure your stuff. I'm sorry, not to secure, is to see the clock. So if the clock is not matching, probably your device will say that, okay, certificate is issued before versus the certificate is installed on the vman is later. So the clock has to be matched so that the certificate can be validated. That's the reason we say the NTP should be there. Other thing is that if you are using an enterprise CA server, install the enterprise root CHN. So there are two type of the certificate which we can use. I'll connect you in detail about the certificate. So one is the Cisco does provide you the semantic certificate to be are installed in every software which they provide, either the software or hardware. You don't need to install any certificate if your root search chain, if you are using the Cisco semantic certificate, or if you are using the enterprise certificate, then you have to install enterprise root search chain on your vManage. I'll show you about that. Okay. So this is how we do the that day we were doing. The first device you will log in on the vManage admin. You will select the one which is having 100 GB space, right? So in my case, I select one, press buy to format, it will power on, and then use the admin as in a credential. Okay. Once you get into it, you will configure this information and will try to connect to the vManage. Okay, so I think for today we have done a lot of theory. I know that it will be overkilling for you if I will keep continue. So let's do one thing. We are already on time. Let's connect tomorrow 9 a.m. again and we'll continue.
Yeah. Okay. Yeah.
Stop.